SWARP comes from an opportunity from the European Union to fill in the grey area. So you have on the one hand the ice pack that has monitoring and forecasting services, and you have on the other hand the ocean with wave forecasting and all of sort of remote sensing. And in between the two there is a marginal ice zone that has both sea ice and waves, and they interact, but there is no monitoring service for that and no information available.
We're seeing a massive influx of shipping and anticipated shipping in the Arctic and the northern sea routes during summer. And that's what SWARP's all around. It's about making sure that that is managed in a very safe and efficient way.
So this motivates a lot the development of efficient operational services. And by that I mean the services that provide information in real time about the ocean.
They need a lot of information on board. They need all the information from they leave port to the next destination. And they need to make sure that they are taking all that information into account. They need to know that this information is updated, and they need to know the quality of this information.
One big aspect of wave-ice interactions is that waves are breaking the ice. So they control the flow size distribution. So when you sail at the sea in the marginal ice zone, you see pieces of ice of different sizes. So it's not all the same size. It has a special distribution. And this distribution is controlled by the wave regime that is passing through.
It was really in the beginning of the 80s when there was an intensive field program, when people became interested in the area of ice which separates the main open ocean from the interior pack ice. And that belt of ice is about 100 kilometers wide, and it is the waves that actually create that belt of ice. And that's called the Marginal Ice Zone.
Originally there was partners with theoretical knowledge of the marginal ice zone, as in University of Otago. And this knowledge was available since the 70s, but it was missing the technical capability to implement it for operational use.
We had the basic understanding that was necessary to begin to couple these things together.
So then we have found partners in remote sensing, doing excellent remote sensing, and they had an opportunity with the new Sentinel missions that give better coverage of the Arctic. And then we have partners in numerical models. Ifremer, ODL, NIRSC have expertise in different types of remote sensing. Mainly it's synthetic aperture radars. Then we have partners in modeling, Ifremer for the wave modeling, NIRSC and NERC in the UK for sea ice modeling, and they're using models, as you will hear from WaveWatch3 for the waves, HICOM and NEMO coupled with the SICE model for ocean and sea ice. It's the first time that these partners work together, and I think it is the first time that they work on the problem of forecasting and monitoring the marginal ice zone.
It's a very, very inspiring field that has a lot of history to it. 200 years before I went to Cambridge, sealers and whalers would take their boats and ships inside the ice cover to protect themselves from waves. Shackleton, in his famous book about the 1914-1917 expedition, in his book called South, describes a situation on Elephant Island where the waves were very, very intense, very large waves running towards a bay where they were camped. And he describes how the ice damped out the wave energy so that it protected the people on the shore. Had the ice not been there, they'd probably have been killed.
Waves are essential to understand what's going on there. They are just controlling the morphology of the ice, and then this morphology combined with the different forcings from the atmosphere, currents, and internal interactions in the ice, they drive how the marginal ice zone behave.
The wave model and the sea ice model exchange information, they interact with each other. So the wave model will break the ice into smaller flows, and the breaking of the flows will change the dynamical and as well the thermodynamical properties of the sea ice. So the sea ice model will advect the ice flows, will also melt them or freeze them, and then it will provide the flow size distribution information back to the wave model to calculate the attenuation.
One important and crucial variable that we are interested in is the flow size distribution. And this, when you look from satellites, is something that you can see when the flows are really large, when they cover a lot of these small pixels. But when the flows are too small, then what you see is something more blurry. So I'm interested in characterizing images that we have, the synthetic aperture radar images, and to extract information about where is the marginal ice zone and what form it has and how it evolves over a season, for example.
So the wave forecast will cover a large domain. They used to stop at some distance from the ice edge, and with this calculation it will be able to provide wave information into the sea ice.
In a climate perspective, when you add that to the story, then you have an immense territory that was never or very difficultly accessible that now opens up to navigation, to tourism, to exploitation of natural resources, and then fishing areas, new fishing areas are also opening up.
The challenges is the weather conditions. So even if we see global heating now, we will have ice in 10 years' time. The winter and the wave will be tough. You will have icing on the vessels. You will probably have polar lows coming up, even more frequent. So I expect that we will have a lot of commercial vessels sailing the Northern Sea route. We see the trend today, that will increase. But they will need far better forecast than we have today.
There is already new products coming from remote sensing. We've seen synthetic aperture radar images that can show waves into the sea ice, and they make these patterns, what we call the Chinese noodles patterns. And that's a novelty. So from there we can deduce the amplitude attenuation of the waves in the sea ice. And SWARP will also provide new models that couple the effect of waves and sea ice in an operational setting. So from there will be new services that will give, at the very least, an indication of when the waves will break the sea ice and possibly how much ice is broken. And it will indicate which flow size you may expect in the margin of the sea ice, and this margin will actually be more mobile. It will move differently than the ice pack. The information will enter different services at different levels. You will have European services like the Copernicus services for Arctic forecasting, for example. There will be national services like the wave forecasting at Ifremer, and private services at ODL that provides remote sensing products. And these services are completely free and open. And the intention is that these services will stimulate other private services this time that can feed on new data. We have one example of such a private provider with Navtor that can prepare targeted information for ship captains that want to go in the marginal ice zone.
Navtor, we were established only 5 years ago, in 2011. And And the aim at that time was to supply the maritime industry with electronic navigational aids. We are really depending on the best possible wave forecast, and especially for NAVTOR joining the SWARP project, we are also planning for the future. We have made now a parallel feed to our nav station that can utilize the SWARP project wave and ice model. All this information that we are supplying is integrated into the nav station on top of the electronic charts. So it's very easy to make a route plan now, waypoint for waypoint, and then add all the other information that they need. And it's very easy to see it along the route.
The Arctic has changed significantly since the beginning of the satellite era. In 1979, during the summer, the ice covered most of the Arctic Ocean. In 2012, the ice cover in September was about 55% less than it was in 1979, and it looked completely different. It looked like the Marginal Ice Zone.
It is offshore industry and say fisheries that may work in a marginal ice zone, but will probably not work in heavy ice conditions. So it has a high value.